table below shows structures of 3 compounds. Compare the structure and bonding. The structure of carbon dioxide is small molecular. Think about the fact you can easily draw a circle around discrete molecules. Magnesium oxide is ionic, and for this one, think about the charges that we give these spheres. This shows us that it's a metal and a non-metal, which is ionic. Ionic bonds together make giant ionic lattices. So in all directions we have ionic bondings. Silicon dioxide is also a lattice, but in this case we don't have charges. We do have lines between spheres. These lines for the most part mean covalent bonds, and they do here. So this is a giant covalent lattice. And then on bonding, small covalent molecules have covalent bonds between atoms, but also between molecules they have weak intermolecular forces of attraction. Magnesium oxide has ionic bonding between a positive ion and a negative ion. And silicon dioxide has covalent bonds in all directions this time, so no weak intermolecular forces. Technically the ionic bonds are also in all directions, so let's put that in. So that's background for us to use in the question. Now the question does say compare, so we would say one has this whereas the other has that, generally speaking. Carbon dioxide has covalent bonds between atoms and weak intermolecular forces of attraction between molecules. Silicon dioxide also has covalent bonds between atoms, but these are in all directions, and so silicon dioxide has no intermolecular forces of attraction. Magnesium oxide also has bonding in all directions, but because ions are involved, magnesium oxide has ionic bonding. So we've described bonding there, let's just put the structure in as well. Both silicon dioxide and magnesium oxide have giant structures, whereas carbon dioxide only has small discrete molecules. Due to the difference in bonding, silicon dioxide is a giant covalent lattice, whereas magnesium oxide is a giant ionic lattice. Now it may be overkill, but we can also talk about the number of bonds being formed in each case. In carbon dioxide, each carbon forms 2 double bonds and each oxygen forms a single double bond. However, in silicon dioxide, the bonding is all single bonds. Magnesium oxide has electrostatic forces of attraction instead of covalent bonds.